Hello everyone. Today is the 30th day of Leetcode 75 challenge. Let's begin with the 30th question. Question 328, odd even linked list. The level of the problem is medium. I will request you to read the question beforehand as I will deep dive into the PPT and explain it in simpler. Now let's understand the problem in the easiest way possible. So you are given the head of a singly linked list. Fine. The task is to group all the nodes with odd indices together followed by all the nodes with even indices. Fine. So basically you are given a linked list. Let this be the linked list, and your task is to group all the nodes with the odd indices together, such as they are saying indices, right? So this is 1, 2, 3, 4, and let this be 5. Fine. So according to them, the first node is considered odd node. Okay. The second node is considered even node. So simultaneously, this will be odd, this will be even, which we have written here, right? This is the thing they are saying. The relative order of the nodes within the odd and even group must remain the same as in the original list. For example, let this be one list. Okay, so here we will take 1, 3, and 5, and here okay, let it be 4, and let it be 2. Fine. So this is the thing they are telling us to do. We have to basically uh, group all odds together and group all events together, and the relative order should be maintained. Like 1, 3, 5 should be all in this manner only, right? So you must solve the problem is O of 1 extra space and O of n time complexity. This is already mentioned in the question. N is the total number of nodes. After reordering, the linked list should remain connected and valid, with all indices nodes appearing first, followed by all the even indexes nodes. So this is the thing they are asking us to do. This is the linked list given, and you have to convert it into in this format, right? I hope you understood what they are trying to tell. The number of nodes in the linked list is the range from 0 to 10 to the power 4. Okay, this is the constraints. And the values would be negative 10 to the power 6 to positive 10 to the power 6. So I hope you understood the problem explanation. Now let's move to the next slide. Now let's understand the input output explanation. So what is given here? We're given 1, 2, then 3, then 4, then the 5. Correct? So all the odd indexes, or we would say odd indexes nodes, should be put together, right? So in this case, we will put 1, then we will put 3, then we will put 5, correct? Then we will put 2, then we will put 3. So you could see the relative order is maintained. We have not written it like 3, then 1, then 5, right? So relative order is maintained. This is 1, 3, 5, 2, 4, which we have got here, right? Now let's look for the this one. Here what we are given? We are given 2, 1, 3, 5, 6, 4, 7. Please don't look at the values, right? We don't have to do anything related to the values. So if you just see here, this is index 1, this is index 2, this is 3, this is 4, this is 5, this is 6, this is 7, right? So if I group odd indexes together to this one, then it is 3. So we will write 3 here. Then it is 6, correct? Then it is 7. Fine. Great. This is the odd grouping. Fine. Then even grouping is 1. Then we have 5 value here. Then we have 4. Correct. So if you could see, this is the complete odd group and this is completely the even group, right? Odd, even. So output is also the same 2, 3, 6, 7, 2, 3, 6, 7, 1, 5, 4, 1, 5, 4. I hope you understood the input output explanation for this problem. Now let's move to the next slide. To understand what problem is asking, we should build up an intuition to the problem. Now, we are given a single linked list, fine, and need to group all the nodes at odd indices first and followed by all the nodes at even indices, correct? So the odd and even refers to the node position. Please keep that in mind. It is event based indexing, not the node's value, right? Okay, let's make something here 1, 2, 3, 4, then 5, then be 6. Fine. Now we need to maintain the relative order of the nodes within the odd even groups. We have to maintain the relative order also. Fine. Now, if we maintain the relative order, which means 1 should come before 3, 3 should come before 5, right? That's the thing. So, okay, this is the understanding of the problem that we have to do this thing. Now, what could we do? We could think of using list data structure to store the odd and even values and create a new linked list from it. For example, what you could do, you could just take a list here, like name it as odd and name it as E. So you could put the odd indexes values here like 1, then 3, then 5, here 2, 3, then 4, then the 6, right? Then after creating this, you could create linked list from them and create a complete odd followed by even linked list as per the question. But but we must perform this operation using O of one extra space, which means you cannot use any extra data structure to complete the solution, right? And the time complexity should be O of n, right? So that could not be done. So what could we do? What other steps you can take, right? Now let's try to visualize this process. Fine, how we could do without using extra, data structure or space complexity. Now try to imagine splitting the linked list into two separate lists. Okay, one for odd and positions nodes and other for the even position nodes. Let this be a linked list 1, 2, 3, 4, 5, 6. Fine. As we move through the linked list, we could connect all the odd nodes together and all the even nodes together separately. Right. This could we could think of this, right? If you're traveling, okay, this is the odd index, so you created one here. Now this is the even index, you created a new list. Right. This is the odd index, so you connected here. This is the even index, so you connected here. Now this is the odd index again, so you created added here in the new linked list, and this is the event, so you created here. Okay, we could do this without using any space. We just created two linked lists from the given linked list. Great. This is the odd. This is the even. Now at the end, when the iteration is complete, we could attach the linked list. For example, this is the linked list for even, right? So what you could do after creating this, this is the odd. You could just join this complete linked list here this way. So if you can see, we got the resultant output. Correct? We got the odd group value here with the relative order maintained, and similarly for the even one also, right? This way we don't lose any nodes and still maintain the required order. Now, how we can simulate this, right? Since we built up an intuition that, okay, we could create two linked lists and join the even linked list back of the odd one, right? So how we can simulate it or how we can do it, right? So what we could do, we could traverse the linked list once using a current pointer. For example, this is the list. Correct, great. So we could create a current pointer and point it to the node. Fine. And we could take a counter. Let me take it here. Counter. Now you will be wondering why we are taking counter. Because there is no indexing in a linked list, right? So you have to know in which index you are basically in. And indexing starts from 1 here, as it is a 1 based indexing linked list. Because the first value is considered odd, so we could take 1 as the odd value here. Fine. So we'll initialize count with 1. Fine. Now for each node, like if you're standing here, we could check that, okay, what is the count? If count uh, if count is not equals to 0, or which means it is equals to, which means it is an even number, so this means that this we are in index we are standing in the odd index value. Fine. So what we could do, we could create uh, two more pointers. Fine, let it be odd, let it be even. Fine. And we could also create two more pointers. Let me write it again. So we could create like pointers such as odd head, odd tail. Similarly, odd, uh, similarly even head, even tail. Okay. Now, why we are creating odd head and odd tail? Let me tell you. What we could do with this is that if the count is odd, we append the node to the odd list. Okay. So what we will do in odd head, we will append this value here. Fine. And if the count is even, now After completing this, the current pointer could come here, right? And the count will always become, of course, it will become 2 here. So it will be an even index value. So we could put that node in our even head. Fine. Now we maintain the head and tail pointers. Now we will talk about tail also for both odd and even list to easily add nodes as we find them. Now we will be wondering what we will be doing with the odd tail and even tail. Now when the iteration is complete, for example, we added all the odd indexes here and all the even indexes here. You cannot keep the odd head in the end, right? For that, when initially when we will try to put the first node, we will keep it in both cases, or we'll point both nodes in this case to head and tail. Now we will just move tail ahead rather than moving the head. Fine. So every time when we will insert into the odd pointer, we will point it to the tail pointer. So every time this is the one, head is there, tail is there for the odd. Fine. Then tail will come here. Or tails next will have the third value. Then tails next will have the third value again. Sorry, this is second value. This is the third value. Then tail it will point to null. Now when this is completed, and similarly for the even also, 2, 4, then 6, then null, right? We could do odd tail. Odd tail next could be equals to head of the even, right? Getting my point? This way we could connect odd tail with even head and complete the linked list cycle. So after the traversal, we can connect the tail of the odd list or odd tail to the head of the even list or even head. Also, we make sure that final node points to the set of none to prevent cycles. So we have to point it to the null because it might create a cycle issue, right? So this is the simulation which we can do and complete our solution. What we try to figure out is that we will maintain two separate pointers, odd and even, for head and for tail, similarly for even also, correct? During a single traversal allows us to reorder the linked list efficiently. The counter count, we will also have C and T so that we could get the index value. Fine. It will keep the track of head and tail for both the list. S because odd tail is there, let it be OT, will connect it with even head. Fine. And finally, by connecting odd and even lists, we achieve our desired output in a clean and optimal manner. So I hope you understood the intuition build-up. Now let's move to the next slide. Now, since we get the intuition of the problem, let's look into the approach, how we're going to solve it. So we will start by checking the base case. Now, what will be the base case? Check if the linked list is empty or has only one node. For example, if there is only one node, so it is of course odd, but we will just return this, right? We don't have to do anything. Or since simply we will return head itself because we have nothing to do, right? Or if it is null, like there is nothing, so we will return head itself, so it will be null. So this is the base case because there is no rearrangement needed. This avoids unnecessary processing when the list is too short to separate odd and even parts. You don't have a list to do anything. Minimum you require two nodes, to go with the stuff. Since you don't have, we will return the head itself. That's the base case. Now the second part is initialization of the pointers. This is the important part. We will initialize odd head, odd tail for managing the odd indexed nodes. Then even head and even tail for managing the even indexed nodes. Right? We will initialize all of them as none because of course, it will start from the none value and eventually we will put the values in it. Now the start pointer current will always point at the head and counter will always be set at to 1. 1 because the first index or the first node of the linked list is odd based. That's why we take it as 1. And current has to point to a head. Otherwise, we will not be able to iterate the the linked list. That's why we take the current pointer rather than iterating the complete head pointer itself. Fine. Now, separating heads and tails help us to build the odd and even list independently while traversing, as we discussed earlier. Okay. Now let's understand the traversing and separating the nodes part, which is the most, you could say, critical part of the problem. So we will traverse the original linked list using cur. Fine. If count is odd, what we will do? We will attach the node to the odd list, updating the odd tail also. Because if in the first iteration or the first time when we will get the value, odd head and odd tail both will have the first node. Fine. But eventually when we will move forward, all the nodes will be attached to odd tail. Fine. And similarly, if the count is even, attach the node to the even list and updating the event tail. We move current to the next node and increment count eventually till the iteration is completed. Now this distributes nodes correctly into odd and even groups while maintaining the original order. Right? Now the final adjustments will be, we will set event tail next none. Suppose this is the even uh, linked list. We have to point it to the null, and odd also we will point it to the null and properly terminate the even linked list. So if we do this, and suppose one of the linked list does not exist, just for example, if one of the linked list does not exist, or you just got only one part, so in that case this has to be a complete linked list, right? So this will result in that part, or otherwise there could be a cyclic error also. Fine. And we will set our tail next to even head. When we have the even value or the even linked list, the odd tail will eventually be connected to the head of the even linked list, because properly joining the two linked lists forms the final required sequence without leftover links or citers. Now we will return the updated head. We return the odd head if it exists. Otherwise, we return the even head. There could be a condition that we don't have any odd head. Okay. So in that case, we have to return the even, right? That is why we give null at the end. That is one of the reason. And second, there could be a cyclic issues also or leftover links, right? The rearranged list starts with odd indexed nodes followed by even indexed nodes. That's why we check if there is no odd, we return the even. Fine. So I hope you understood the approach. Now let's move to the next slide. The code is the exact copy of the approach we discussed. Let's understand it line by line. Fine. I understand the code is a bit longer here, but I will try my best to explain it to you. The head is none. The head next is none. We return head. Fine. There is no head only. Okay. Or if there is only one node, we'll just return head. We don't have anything to do with it, right? Otherwise, we will initialize current with the head pointer, current pointer to the head, and all this even head, even tail, odd head, odd tail, as we discussed earlier, will be pointed towards none. Fine. And the count will be one. Fine. We have this idea from the earlier cases. Now, this is the main part. While it is not null, if it is an odd, it says here if odd head is none, which means this odd head pointer is pointing to none, means it does not have anything right now. Fine. So which means that this is our first value for the linked list, correct? It's a common understanding. Let me clean it up. Odd head. Fine. So what we do, we put odd head to the current value and odd tail also to the current value, because both has to point to the first value, and there eventually if you see in else case we just push the or we just move the tail pointer for the odd case, because odd head is head and odd tail has to be the tail of the linked list for the odd part. That's why we keep on moving it. Fine. If the count value is even, so if even head is none, even head is initialized with current, and even tail is also initialized with current, so that if next time when the value comes up to be even indexed value, we just move the event event tail pointer furthermore, fine, till the the linked list gets ended, and we increment the count, and count current next is done, right? After this complete while loop is completed, we check if there is event tail or not. If it is, we complete the linked list with having pointing the last node towards the null, and similarly for the odd also we check if it is there, we do the same. Now if odd exists, if odd head exists, okay, so what we do, odd tail next will point to even head. Suppose this is the even value, right? Just suppose, and this is the odd. Let it be odd, let it be even. So if you have keep in mind that even tail is here and even odd tail is here and even head is here, so odd tail next will be pointing towards even head, which we do it here. It will connect the complete linked list and we will return the odd head. Otherwise, if odd head does not exist, we put the complete even list into the odd head value and we return the odd head. Right? The time complexity for this comes out to be O of n because we only complete the solution in single pass and there is no extra space to use here, so it is O of 1. So I hope you understood this code explanation. Now let's move to the next slide. Now since we have the understanding of the code, let's look at the dry run of the example. So for the dry run, let me do one thing. Odd. This means odd head, fine. And let it be odd tail, fine. This is one thing. And let's take this also. Since it's a shorter example, what we could do, we could just create, I will just make a divider here and even head and even tail. Okay, that's the thing. Fine. And I will just draw the complete linked list here. 6, then 4, and 7. Fine. And we used to keep count equals to this be the stuff, and I will write count here. Fine. Count is 1 and slash to 1. And let's see with the current, which is pointing to the head of the linked list. Fine. We are ready with our parameters. Now let's start. So the count is 1. First we check if the count is odd or even. Since we can see it is odd, so this 2 comes here and gets initialized to odd head and odd tail. Fine. Great. Now we move count to the next part. The count current is here and count is increased to 2. The count is even. So this is 1. This comes here and gets initialized to even head and even tail. Great. Now this moves ahead again and count also increases. We could see count is odd. So this 3 comes and joins the odd tail. Okay. So head is here and tail is here. Fine. This is done. So we increment the count and this is also incremented till here. Okay. Now the count is even. So this 5 comes here and joins even tail. Fine. This is the tail and this is the head. Okay. I've just written it separately so that you can understand that this is the head and this is the head for odd and even. Fine. Now this moves again further and increments the count. So the count is odd and the value is here 6. So it comes and gets attached here. Tail comes here and value increments again to 6 and this moves here. So this comes and joins here with the tail part for the even the next. Great. Now again the count increases to 7. It cuts down and comes here. So we have 7 here and tail moves here. Great. Now the iteration is complete. Fine. I will remove this count now. Iteration is complete. Fine. After iteration complete, we used to check whether there is odd tail or not, or odd head or not. If it is there, we used to pull we used to make it none. And similarly for even, we have to check whether even header exists or not, right? If you could remember, we used to check if even tail exists or not, or tail exists or not. If they, we used to point the last pointer to the or last node to the none. So here we did the same. Great. Now after that, we used to check whether even tail exists or not here. Oh, fine. If odd head exists, we should check if odd head exists. If it exists, which means that even head obviously exists, right? So what we used to do, tail is standing here. Now tails next, we remove this. Now what will happen? tails next, or we could say odd tail dot next will be even head. Now even head is 1, correct? Which is this. So it will get an point to this value. Fine. And our final list, our final linked list will look like this. 2 pointing to 3, pointing to 6, pointing to 7, pointing to 1, pointing to 5, pointing to 4, pointing to none. Fine. So if you could see the output 2, 3, 6, 7, 1, 5, 4 and 2, 3, 6, 7, 1, 5, 4. Fine. So this is the complete dry run for the problem. If you have any doubts or confusion about the solution we arrived at and how we arrived at it, I would suggest going back and understanding the intuition, the approach and the code. After that, do a dry run by yourself on 2, 3 examples, and I'm pretty sure you will understand both the solution and the thought process behind it. Now let's move to the next slide. Now, since we are familiar with the problem and the solution, let's move to the lead code and code the solution. First, we will check the base case if head is none, or if or head dot next is none, then please return head. Fine. If it is not true, then we will point current pointer to head, and we will create even head, even tail, odd head, odd tail, and we'll point everything to none. Then again none, and now this none is representing each pointer. Fine, this is done. Now we'll also make count here. Count equals to 1. Okay. We have initialized all the pointers. Now while current is not null, if count is not 0, which means it's an odd value. So, okay, if odd head is none, so odd head will have the current and odd tail will also have the current. Else, if odd head is not none, eventually, which means that we have the first value for the odd. So odd tail next value would be the current, and odd tail will come to the next latest value added. Right? Else, even if even head is none, and even head is equals to current, even tail will be equals to current. Else, similarly, the same as odd, even tail dot next value would be the current, and event tail will move to the latest value, which is event tail dot next, which we added right now, right? So event tail dot next. After this, we will increment the count, and we will move current to current next. Else, event tail. Okay, now let me now we will check if event tail exists or not. If it exists, then event tail dot next would be none. If odd tail exists, then odd tail dot next would be none. After this, we will check if odd head exists or not, which means we have the linked list for odd or not. We have. Fine. What we will do? Odd head dot next would be even head. Else odd head, we will put even head there, and we will just return the odd head. Now let's try submitting the solution. Okay, we have some mistake here. Okay, I figure the issue was here. I wrote odd head instead of odd tail. Now let's run again. Okay. Now let's submit the solution. So we have submitted our solution successfully. Now the code of the problem is available in my GitHub repository. You can find the link in the description. Thank you everyone.